Hello everyone, this is lecture 2. The topic of this lecture is x86 registers and basic assembly coding. So basically we're going to talking about the architecture of x86 CPU processor from Intel, and we're going to explain the general purpose registers within this architecture and then briefly explain the basic assembly syntax. So the first 16-bit processors of Intel CPUs introduced in 1978. So this CPU is a 16-bit CPU, and we call this family of processor x86 CPU architecture. So this is the first generation of 16-bit processor in Intel production CPU line, and the reason that we call it x86 is because the generation coming after these CPUs also have 86 in their model number. For example, we have 186 generation after, and then we have 8286, and then we have 8386, and so on. Therefore, we call this family of CPU simply x86 architecture, as you can see from here. So it can be just summarized as x86 architecture. So this class of CPUs normally are being used today very widely. In fact, 80% of computer desktop and laptop are, more than 80% are using this family of CPUs. That's the reason our focus on this course is on x86 architecture. The next widely used CPUs are ARM processors. So there are different family of CPUs normally used in embedded systems, where you can find those CPUs in, for example, kitchen appliances, in your smart fridge, or even in a smartphone. These CPUs are belong to the family of ARM processor. So in this course, I focus on x86 architecture, and normally in embedded system courses, the focus will be on ARM processor. All right, this is the high-level overview of x86 system architecture, where you could classify the whole system in three parts. So there's going to be CPU here, then you're going to be having the bus interface in the middle here, and then you're going to be having memory located in this place. So CPU in general contains a general purpose register and arithmetic logic unit, as we will be explaining next. And then we're going to be having the bus interface unit. So this is bus interface unit, where the purpose is to transfer the data between the CPU and memory unit. So normally bus interfaces composed of two, normally address bus and data bus. So the function of address bus is to tell where to write or read from memory, and data bus is responsible to carry the data from memory to the CPU, or from CPU to memory. The memory itself consists of two main sections. So one of the section normally store data, and the other section store the machine code or instruction code. Data are normally the inputs or the output of the system that comes from peripheral or goes to the peripheral. And machine codes are those instruction sets that tell the program what to do at any given time. So this is the general architecture of the 8086 interprocessor. Basically, as you can see from here, the system is divided into two main units. So the first one is the bus interface unit, and second one is the execution unit. Execution unit is basically the brain of the CPU, where all the processing is happening in there, and mostly the arithmetic logic unit is there, where it is responsible for addition, subtraction, and basically mathematical operation. And then you're going to be having a general purpose register in here, where these registers are kind of a memory unit that stores temporary data. For example, if you want to add two numbers together, one can be stored in this register and the other one can be stored in the second register or B register. Then they come to the arithmetic logic unit in here, and the arithmetic logic unit is going to be adding them together and then send it back to the data bus. Depending on the instruction, then this data could go out to the bus interface, and from there goes to the memory, or it could come back or feed into the program to be used in other part of the code. Intel 8086 registers are listed here in this slide. So as you can see, we have register A to register D. So we call it register AX, BX, CX, and DX. These are 16-bit registers, where each composed of two 8-bit registers. For example, AX consists of AL and AH, and register BX, CX, and DX having the same feature. But the stack pointer register and, for example, instruction pointer, they are register of 16-bit length. So we cannot have like lower 8-bit part or higher 8-bit part for this register. This is hold also for segment registers. They are 16-bit and they cannot be addressed in 8-bit resolution. So as I mentioned, so register AX is a concatenation of register AL and AH, where each one of these registers are 8-bit. Okay, here we're gonna briefly talking about the structure of assembly code that we're gonna be writing in this course. So basically, you could divide your program in three main sections. As you can see here, the first section is for label, and the second section is for the instruction, and the third section is for the operand. So it is nice if you could structure your program in this way so that other programmers or readers can read your code. All right, let's take a look at some basic assembly coding. Here, our code, these examples are given in the Intel form of assembly composition. So the first command is move command. So move y to x. So this one is move xy, meaning that you have the register y, then you put the content of that register into register x. Basically, it's going to be x is the destination register and y is the source register. And then you have exchange xy, means that you exchange the content of register x with register y. Increment and decrement are similar to the C instruction. And so basically you increase the value of register X or decrease the value of register by 1. Here we have add and subtraction operation. So it means that you add the content of register X to Y and then put this result into register X. For subtract, you subtract X from Y and then put the resultant into the X register. Negation actually creates or produce the negative value of the register X for you. And here are bitwise operation that in assembly. So and, or, XOR, and not. These are similar to those instruction in C language. Basically, if you have X and Y as 16-bit registers, the operation gonna be doing, for example, for AND, gonna be performing AND between each corresponding bit and put the result in X register. Here we have some explanation regarding this syntax. For example, as we said, X plus Y gonna go to register X, X minus Y gonna go to register X. So it means that always the first one gonna be your destination operand or destination register. We explained this in the previous slide. There are some example of assembly coding for x86 architecture. In the previous slide, we have a notion of X and Y, which could imply, which could actually refer to a register or a memory location. So here we are directly work with the register names. For example, in this command, we have move command that works on register AX and BX, meaning that it will move the content of register BX to AX register, and so on. Here we move number 1 into register AX. In here, we substitute the value of register AL with AH, meaning that we put content of AH register into AL register. Here we load register CL with number 123. Here we have variable U that we dereference and we move its content to register AX. U refer to a memory location that we define in program at the beginning of the program. Then we put a bracket around it, meaning that we dereference that memory location. And then here we have a kind of reverse operation when we move the content of register BX into a location pointed by the variable. Here we move number 12 into memory location V. Here we have the operation shown in red, meaning that this operation is not permitted in x86 architecture. Basically, the operation says that move the content of U into a location pointed by V. So, two operand cannot be in memory location. So the solution for this is to first move the content of the memory location U into AX register and then move AX register in location V in the memory. So it means that when you want to move the content of memory from one location to another location, the CPU has to be in between. So memory cannot exchange content without CPU supervision. So then Therefore, we take data from memory, we put it in the CPU, we process it, and then we put it back into a memory location. So here we have another example. We have add operation. So here we have some example of add operation. It's kind of similar to the previous one. Here we add bx with ax and move the content to ax register. Here we actually add 1 to the value of ax register and so on. The only thing that is kind of tricky is this operation. So we cannot do this because these are two locations in the memory. Therefore, we have to move the content first into the CPU and do the addition. So the solution is given in here. So we move the content of u into AX register, and then we add that AX with the content of the memory at location V, and then put the result at V location in the memory. Here we have more example regarding the simple assembly coding. So in here we're gonna be doing deducting AX from 10 and then multiply the content by 2. So far we haven't talked about multiplication. So the purpose of this exercise is to do the operation using the assembly syntax that we know so far. All right, so let's see how we could do this first operation. So what we can do is we first move the content of register AX into BX, and then we subtract the value of BX by 10 to produce AX minus 10, and then we add BX with BX. When you add a register by itself, it means that you are multiplying its content by 2. As simple as this. How about for this one? So we have AX register, we increment it, we produce AX by 1, and then here we add register AX by itself, we produce 2AX, and then in here, again, we add the content of AX with AX, so this time we produce 4AX, and then that's 4AX, and finally we produce 8AX by adding 4AX with 4AX. Therefore, this one is 8AX. So the solution for this is given in here. Just go through that, and if you have any question about it, please feel free to ask me. So far, we talked about the 16-bit register family from Intel. So three or four generation of x86 architecture has 16-bit register. So they start from 8086 to 8286. So and then we have also 8186, which also is a 16-bit process. Basically, 3 generations have 16-bit processor length. And then the next model in this family, which is 386, which is also known in the literature as IA32 or I386. This CPU has 32-bit registers. So the first one is EAX register. EAX register is the extended version of AX register. So we have 16-bit in here, and then we have added one more, concatenated one more 16-bit to it, so it becomes 32 bits. We have register EBX, which is the extended version of register BX, ECX same, EDX is the same, and also other register has the extended version. All right, in this course, we will be dealing with the 32 bits length register, or are focusing on x86 with 32-bit length register. So 64-bit register family, 64 bits hardware architecture also exists in Intel family. So today's laptop and computers, desktop computers, all they are having 60-bit general purpose register. So the structure of this CPU family is almost the same as the first generation. They consist of the CPU, bus interface, and memory units. So for the 64-bit processor, the naming convention is different in that the 64-bit register normally starts with the letter R. So here you have 32-bit version, 32-bit length, and then you have an additional 32-bit in here. So altogether it's going to be 64-bit. But still you have your register AL, register AH, and register AX, meaning that you can work with registers with length of 8 bits as well. So this is register A. So we're going to be having the same thing for register B, C, and D. In 64-bit processor, we also going to be having 128-bit media register, which are these registers. And also we're going to be having some register assigned to floating point operations. So these are these registers. And also we have flag register, which is also 64-bit, but the 32 higher bit is 0. And this instruction pointer also 64-bit, where we use the EIP part of that instruction pointer. And here are the naming for the general purpose register, which, as I mentioned, they normally start with letter R. This concludes our lecture 2.